Dear students, Assalamu alaikum and welcome back to Angiosperm Morphology course with the discussion of branching in stem. We were discussing the Cymose branching. If you remember in the previous video, we saw the first kind of Uniparous Cymose branching, and that was scarpoid or scarpioid branching. Next is the Helicoid Cymose branching. As we know that the branching pattern in Cymose, the various kinds of Cymose, is the same, and that is the main axis it stops growing. So the same case here in Helicoid branching, and let's this time state it a little differently in terms of flower. So the main stem or main axis, what happens that it ends in a flower. So this is the main axis and it has ended in a flower. Now what happens, since it's a uniparous cyme, so it gives off one branch, single branch below the apex. And again, like in scarpoid branching, we have two options, that this particular branch can either arise from the right side and it can also arise from the left side. So it depends upon you which option you select. In both ways, the pattern will be the same, either right or left. So in case of scarpoid, we selected the right side. Say in this case it branches on the left. So below the apex, say on the left side. So it will give off a branch on the left side, and just like the parent axis, this branch will end in a flower as well, and it is arising in the axil of a leaf. So this is the leaf and this is the branch which has ended in a flower. So up to this point, the branching pattern is the same as far as both scarpoid and helicoid are concerned. But the difference is the next, for example, this is the first or the main axis, and this is the first daughter axis or second branch. So this branch also ends in a flower and gives off a branch below the apex, but on the same side, and that is on the left. Since we are on the left side, so this particular branch, it will again end in a flower and it will give off a branch, say this is the leaf, and another branch, and it has also ended in a flower. So as you can see, the branches are arising on the same side. Now you can shorten it a little. Instead of writing all this text, you can say that this particular branch, that is the next branch, the first daughter axis, it repeats the same pattern. That is just like the parent axis, it ended in flower and then it will branch on the left side. And the next daughter axis, number 3, it will again end in a flower and it will produce branch on the same side, that is on the left side. Here we have a leaf, and this branch has also ended in a flower. Our diagram has come quite close to the text anyway. And now to wrap up, and instead of writing it again and again, we can simply write a single sentence that this pattern of branching is repeated by the subsequent daughter axis. So this is the main axis ended in a flower and it produces a branch say on the left side, it again ended in flower, and it will produce a branch, single branch below the apex, and on the same side, on the left side, and it will end in a flower, and it will produce a branch. It will end in a flower and it will produce a branch, and this process is repeated by the subsequent daughter axis. So what will happen, as you can see, that we are getting a somewhat spiral pattern. If you just continue it, leaf, and as you can see, we are getting a somewhat spiral pattern like this. It keeps on branching, and this is the Uniparous Helicoid branching. So you can take either the right or the left side, and the pattern will be the same. So if it is on the right side, we will get the same pattern. So we have a leaf here, and a branch ends in a flower, and then a leaf, and so on. So as you can see, we get now a spiral on the right side, and this was spiral on the left side. In either case, it forms a spiral, but just like scarpoid branching, the daughter axis, they tend to straighten out, they tend to get themselves straight. Now when they straighten out, as you can see, all these upper portions above the leaf, they will be displaced to one side, and all these leaves, they will remain on the opposite side. Before working it out ourselves, let's see a diagram. So here is a diagram right in front of you. This is the first or the main axis, and as you can see, branching, it ended in the flower and it produces branching on the left side, and the next one is also on the left side, and on the left, and on the left, and we are getting a spiral structure. But in nature, what happens that these branches, they tend to get themselves straight, they straighten out. So what happens that these tips of the branches with the flowers, they are displaced to one side, as you can see, and the leaves, they remain on the opposite side. So this is helicoid branching like in linum. Now let's try to work it out ourselves. So this was the main axis, it ended in a flower, and it produced one single axis below the apex on one side, say on the left. Okay. So now what will happen that this particular, it will try to get itself straight. So when it will straighten out, this particular upper part of the parent axis, it will be displaced towards right. So again, like in previous diagram, let's use different colors. So let's use this magenta color for the parent axis. So up to this point it is straight, this is the parent axis, but now it will be displaced. Its upper part will be displaced, and here is the daughter axis, and here is the leaf. So as you can see, this is the parent axis, it has been displaced towards one side. So what happens, again a new branch is born or given off, like here. So we have, when this branch, the branch number, for example, this is 1, and this is 2, and this is 3. Branch number 3 or the third axis, when it tries to get itself straight, or when it straightens out, it will displace this particular axis. So what will happen, that this particular upper part will be displaced towards the right. So first let's draw it. this is the leaf, and this is the next axis. So when it will straighten out, it will displace this particular axis. So let's again use different colors. And now this particular axis, it will also, its upper part will be displaced towards the right. And finally we have the third axis, right? And the leaves, they will remain on one side. So all the leaves on one side, and the upper parts of all the axes, they will be displaced towards the other side, as you can see. So this was helicoid branching. Now you can see that the main axis, which seems to be a single axis, this is actually a sympodium. So this is a sympodium or sympodium, as it has been formed by the bases of the subsequent daughter axis. So this is the base of the main axis, and this is the base of the first branch, and this is the next branch. As you can see, this, which seems to be a single axis, is actually a composite axis and made up of bases of the subsequent daughter axis. So this was helicoid Cymose branching. Hopefully you get the concept and you get the idea that what happens when a helicoid Cymose branching starts, and in the initial stage it is just like a spiral, as we have drawn here. It's more like a spiral, but when these branches, they straighten out in this way, and this one will straighten out in this direction. So what will happen, that these upper parts, they will be displaced towards right, and in this case they will be displaced towards left. And the axis that seems to be a single one is actually a composite axis, and it is formed by the bases of the subsequent daughter axis, as you can see it here. So more about Cymose branching in the next video. Thanks for watching, and see you in the next video.